We are live. It's another great day in the land of Cribl TV. It's Ed Bailey from Cribl, along with Eugene from Cribl. We are so glad to be here today. We are going to talk about reference architectures today. I am so excited. It's a Friday, but you know what? This is more exciting than Fridays. How are you doing today, Eugene?
Good, good. It is Friday, and it's the thank God it's Friday, not the oh my God it's Friday. So I'm ready for the weekend.
There you go. Is for your kids? Is it getting toward the end of school?
Yeah, actually, my daughter's a senior. Today is her last day of school. She's done. That's it.
Wow. It's going on to college or anything like that?
Yep.
There you go. Yes, it's day's my last day of school for my kid. It's going to be fighting between, hey, you can't sleep in all day. She's 12, going on about 30, and so it's going to be lots of, hey, you can't sleep all day. Why can't I sleep all day? Versus get a job, earn some money. So yeah, it's going to be a fun summer.
Yeah, for sure.
So the weather, I'm in Atlanta right now. The weather's great. It's actually mild. It's a little crazy. Eugene, how's the weather where you are?
It's actually pretty nice, except for the pollen count. But well, that's why I'll be coughing periodically.
Oh
Like
yeah,
right
nonstop thing. I have a air purifier under my desk for a reason because
now.
the pollen is something crazy. So glad to be here today. So we are in as a part of our long-standing and probably never-ending, when emphasized never-ending, um, live streams about the Cribl reference architecture. We want to then go through the process of pretending you're a customer and working with your professional services representative of how to plan your deployment. So I'm going to play the role of customer. Eugene is going to play the role of expert professional services guru. We're going to go back and forth. We're going to ask some questions. If anyone's watching who wants to ask questions, please go ahead. YouTube, Twitter, and LinkedIn, because we want to hear your feedback. We're just try to use this as an exercise to help you think through your process and plan your deployments. And of course, we cannot have a live stream without some slides. Make my boss happy. We're going to have some order, some organization, hopefully professionalism added to the stream. So here's some slides. Yay, architecture planning. As we've said before, Oprah gives out gifts, and she also gives out reference architectures. Everyone gets a reference architecture. Use the QR code to pull up this nice handy link. Also, I would not be in marketing if I did not mention that we have Criblcon coming up, July 17th at the Mirage in Las Vegas. All day content fun. We're going to have sessions, customer sessions. We're going to have sessions from the Cribl goats where we're talking about how to use Cribl Edge, stream, and search. It's going to be lots of fun. It's going to be a good time. Demos. We're also going to have a very large party afterwards. And so 99 days for a full day of content plus meals. So it's going to be a good time. I hope to see lots of people there because I think it's going to be great. Best part of my day is meeting our users, talking to admins, and talking to engineers. Eugene,
Yeah,
go.
I'm not in marketing. And I'm excited about it. I don't know if
Yeah,
I'll be there, but it's awesome.
yeah. Hopefully you will be because I think it's great, and that way it'll be good weather, and so we'll have a really nice time. It's something I'm really looking forward to. So let's get into architecture. And so, I mean, it is the thing that when someone says it to you, you want to hit them over the head, but it is kind of true. And so, Eugene, so when you go through these, you do this, you work with customers, help them plan out your deployments. I mean, do you say it depends, or do you say something else that's like depends, but not quite depends?
I basically do end up saying it depends, but I prefix it with the well, yes, the standard consultant answers it depends, but in this case, here are the things it depends on, and then we dig into how specifically it affects them and
Right.
what the answers are for them.
Exactly. I think that's important because you're making a series of choices, and that's where the it depends come line. It depends on your context. It depends on your needs. And so I think those are the things we're going to go through. So let's start asking some questions. So where do you want to get started? So when you're planning out an architecture, what's the first question you ask a customer?
Usually, we start with what sources they have and what destinations they have, just to get an idea of what sort of things we need to dig into, and volumes and so on.
Okay,
So
so let's say that I have, you know, 60% of my business is syslog. It's going to be a mixture of Palo and Cisco. The other 40% is going to be application logs and my cloud logs, and that are going to be coming over, let's say Kinesis, and also coming over Splunk Universal Forwarder.
I have to take notes because then I have to remember what you actually said.
There will be there's going to be a quiz at the end.
Yep. Okay, and also by the point that we are meeting, it's probably already been established, but the goal of the deployment could be different, right?
Right.
So in your case,
let's talk about the goal. So our goal is a mixture of cost controls, but also we want to be able to get the right data into our SIM. We want to get rid of the fluff and get the right data into our SIM, and also be able to take advantage of the data lake.
all right.
So in terms of destinations, it would be Splunk or AKA Voldemort. And then also we can talk about a data lake. So let's pretend it's Snowflake.
All right.
And so we've talked about our sources. We've talked about our destinations.
So volume-wise would be the next thing to dig into, because basically what at this point I'm looking for is, do we have anything that needs more digging into for concerns of it's going to be too big of a volume that we need to adjust the architecture to handle it, or are we getting 100 gigs a day overall? Like I have a customer total 170 gigs a day. Okay, we're good with the smallest possible option and not have to dig into a bunch of others. So Ed, in your case, what are we looking at?
Well, I want to be able to get the fluff out. So I think it's about 30%. So if we can get rid of about 30% of the fluff and then bring in other data sources to replace that.
30% of the fluff, that's percentage-wise. What are we looking at in terms of actual gigabytes per day?
Let's say 10 terabytes. One thing I want to back up, though. So let's talk about our technical and business objectives. My business objective is cost controls, quality, and also risk control. So getting the right data into my SIM in order to drive better detections. My technical objectives is I need something that's going to be scalable, something that is going to be highly available, and also easy to use.
Okay. Yeah, then that makes perfect sense. And that's actually one of the other things and that I was thinking when we were talking about it depends, right? Just as we were getting ready for the stream, we were talking about, some customers, we must have 100% data or as close to as we can all the time. Others like, if we have a gap, it's not that big of a deal. We'll catch up later. So, and that will very much depend or very much affect how much money you're going to pour into the solution, right?
I think that's something. Let's really talk about that, because zero data loss versus a little data loss versus there's a big difference there.
Yeah, for sure. So I think in the architecture document that was linked and a bunch of places, it really comes down to your money versus risk, or other. Yeah, you're trading off one for the other.
Always.
If you put more money into it, more redundancy, HA, it's going to cost you.
Perfection does not exist. You're always going to have to make choices. That is absolutely the truth. All right, so we talked about our business, we talked about our technical. So let's go and get into the weeds. I think sizing is very important. So let's talk about that. So let's say we got 10 terabytes a day as my daily average.
Yep. So daily average is great, and we have the start of that conversation with these sizing considerations. There's documents on that. There's a sizing calculator out there. I'm not going to break out the sizing calculator to get the exact sizes because we don't need that on the stream. But that gives you the average daily volume, right? But very rarely do we see exactly flat average throughout the whole day.
Right.
Very often you see this, everybody comes into the office, right? If you're collecting endpoint data, it starts going up. It's, right, you're getting your Palo Alto traffic, right? Your firewall's logging. So that increases. So if you just look at kind of the whole day, but as a regular curve, you start seeing, oh, maybe, you're getting to twice your daily average or 50% over your daily average just without any other considerations yet.
Right. So would you call that spikes? So you want to be able to scale to handle your spikes in data?
Yes, but I wouldn't even call that spikes. That's expected, right? It's
Right,
not
okay.
an unexpected thing. It's just, during the busier part of the day, you're going to be expecting this level of traffic, even if it's completely even, right? But in your calculation now, instead of pretending that the whole day is averaged out, you're going to take that and pretend that, the busiest hour, let's say that's expected busiest hour, and multiply that by 24, and now you got your daily ingest as one example. Right?
And I think this is critical. I think I see customers make mistakes in terms of planning for my average instead of planning for my spikes, or planning for like a business resilience requirement of, say, we go to 2 or 3x data. Because and I think the thing, it can't be, it's not that everyone needs this, just we ask you to think about it and plan for it. Because if you don't care, that's fine. But it just want people to think about it.
Yeah, as one wise person who's on the other side of the video from me once said, right, you're going to fail at some point. You got to figure out when you're okay to fail. You plan for failure, and then you decide where's that money and failure intersect, and
I think that's the key decision. Yeah, and as an engineer, your goal is for your bosses to ask these questions, and your bosses get paid to make the risk management decision of, we're going to pay for this, but we're not going to pay for this, because perfection doesn't exist. Perfection is not attainable. It's typically too expensive, and most of the time, simply not worth the effort. So you have to look at what your business needs and make those decisions.
Yeah, and if you try to make a car that's crash-proof, it's a completely different situation than a regular car.
Yeah, the only crash-proof car is the car you don't drive. And sometimes not even that.
Yeah. So I think we talked about the expected average, and then Ed, you started getting into the spikes. So that's the other thing. And again, the consideration document talks about it and gives you some math, which I don't remember off the top of my head. But if you look at your busiest minutes, right, and if you have something currently going into a sim or some other system of analysis, you can go and see, okay, historically, what are our busiest times? For example, I was just working with a customer this week, and we were looking at why is all of a sudden our CPU spiking to 100% on some of the workers. And it turns out that LDAPs, all of their LDAP servers on the hour just dump a whole ton of data to syslog. And it's multiple times what we normally see.
Right. And it's a big deal. And just understanding that behavior really helps. And that's why I think building in some extra is important. So just the math that Eugene's talking about is typically one full core for 400 gigs of data in and out. Because you always want to remember, you have data coming in, but you also have data going out to your data lake and to your system of analysis. So for example, mine's 10 terabytes. I got 10 terabytes going in, but I got 20 terabytes going out. And so that's 30 terabytes in total when you start your math.
Good point.
And that's why I cheat, because I'll take that number and I'll say 3 cores per terabyte. That's really 1.2 terabytes, but that gives you a little bit more padding.
Mm-hmm. Yeah, there are all sorts of kind of rules of thumb that you can calculate for yourself and say, oh, I know the size of my workers, so it's going to be, a terabyte per worker or whatever it is, right?
And this is also where I think your distribution becomes so important. So let's answer a couple more questions, and then let's talk about sizing planning for types of data, because I think that's another important consideration. So we already talked about scaling. We talked about scaling, because planning for average versus planning for spikes versus planning for worst case. Let's also talk about planning for HA. So what's your recommendation? So I need an HA design. So what are the elements that would make the design highly available?
So one thing is, if we're just looking at the worker process, at the tier of processing data, you want to have the ability to have one worker down in a worker group at any given time, assuming your load is evenly distributed across all the workers. And that assumption is, well, something we can dig into in a little bit. But the idea is at any given time, if one worker is down, that should be considered normal, as in you shouldn't be overstressing your system and building up persistent queuing or anything like that. It should be your kind of maintenance mode type.
I think that's typically called like an N+1 model.
Yeah.
And I think that's important for a number of reasons, because, and this is where, if you need a load balancer, if the protocol requires it, use a load balancer. I've seen people point their network devices directly at a syslog server. I wouldn't recommend that. Please, my God, use a load balancer. Also have, regardless of the load, have 2 Cribl workers at minimum in every worker group. So that way, you need a patch. You need, if a server fails, you need that. You need those HA options. Are there any other HA options or guardrails or guidance that you can give?
Well, you also have your leader, right? So there is HA leader capability, and the leader is involved in some of the types of data collection. So collection being key here. So if you're collecting something, or if your leader needs to coordinate what files are being retrieved by which workers, like for example with S3, if you're doing a collection there, you will discover what files need to be collected, but then the workers will get their orders from the leader when they check in. And that's if you have that situation, that's critical that you have data coming in all the time. You want to consider HA leader. The other side of it, the workers, if they're, for example, collecting syslog, they're going to be continuing to do their job even if they can't talk to the leader for some period of time. Whatever the latest configurations they got, the configurations they're going to continue processing with.
Yeah, and I think that the making your leader HA is a strong argument for using Cribl Cloud. You can do that with the on-prem leader, but it's a strong argument for Cribl Cloud.
For sure. Yeah.
So let's talk about also the distribution of data. So what do you mean when you're talking about even distribution of data?
Yeah. So for example, one of the things we talked about is Palo Alto syslog. Palo Alto can collect different ways. So what I see in a lot of cases is you have the panorama collector where all the firewalls send to one place, and then it sends on to whatever syslog destination it's going to. And what can happen there is if it's one big stream and it's not broken up correctly, you're going to end up sending everything to a single worker. So in a case like that, let's say if you're using a syslog UDP for collection, you want to really make sure that your load balancer is breaking up that traffic rather than just saying, oh, you want to talk to somebody? Here's somebody to talk to. Keep talking until you're done. Well, that might be hundreds of gigabytes. And a single worker is not going to be handling, or a single worker process is not going to be handling that. So breaking up that traffic is very important. So when I hear somebody mention Palo Alto, that's one of the first questions I ask is, okay, is it going through Panorama or is it going from individual firewalls? If it's going through individual firewalls, what's the biggest volume from the firewall, so we can start seeing how to handle that. Do we need to dig further into, because it is overhead for the load balancer to break up the UDP traffic into datagrams.
Does it matter whether it's UDP or TCP? Would you still use a load balancer?
Yes. So in case of TCP, that's the connection needs to be interrupted by something in order for it to be reestablished. Reestablished. So you still want a load balancer in any case, because if nothing else, like you mentioned, high availability is a concern. So even if you have 50 gigabytes a day going over a TCP connection, and you should be fine just talking to a single worker process, you still want that load balancer in the path for high availability.
Right. So when I tell my network guys, like, I want a load balancer, do I just send all the data over one pool or one port, or should I break it up?
If you have the choice, you should break it up. And we talked about it there's documentation on syslog practices, and it talks about how you want to split up. So in your case, you have syslog from Palo Alto and syslog from Cisco. You want those on different ports, because if they come in on different ports, then for you to decide what to do with them in Cribl is going to be much more efficient, because if you don't have them broken up, you have to inspect the raw of the events and figure out, okay, based on format, which one is this? If they're coming in different ports, you just says input ID and done, and that's much more efficient than inspecting the raw.
Yeah, totally. That makes sense. I mean, so you're using your pools, that you're using your load balancer pools as a way to break up your data through the load balancer. What's that called when the data just sits and pins on one process?
Well, pinning is
Oh,
what.
pinning. There you go. I got it. Yep. Well, that makes a lot of sense. So one thing is there anything about Cribl is does it scale well vertically or scale well horizontally, and how does that relate to data distribution of data?
Oh, well, it depends. If we're talking about horizontally, so if you can spread the traffic evenly across lots of workers, then your horizontal scaling behind the load balancer, or universal forwarders, you just went with more, right? As long as you can spread the load, you can scale horizontally, add more workers to the worker group. You can increase the size of an individual worker to a point, but you have both options.
Okay, I was just more is the worker process pegged to one core, or is it multiple cores?
So each worker process on a worker is going to be using one core or one virtual CPU, depending on if you have hyper-threading. And the virtual ones are going to be able to process less data than the physical ones.
Right.
But it's still, once you're talking to an individual worker process, that's going to be at most one physical core that you're able to utilize.
Okay. And I think I remember that from the docs that it's 200 for a virtual core, 400 for a physical core.
In plus out. Don't forget the in plus out.
Oh, that's exactly right. Absolutely. All right. So we've talked about that. We've talked about the mechanism. We talked about HA. We talked about, and I think that's an important consideration that now that I understand it, thanks to you telling me about it, is that we're going to scale horizontally really well, but only if we can get broad distribution of data. So where would getting broad distribution of data be a problem? Where do you see that with your customers being the biggest issue?
So what we often run into is like the example of Panorama, right? Everything being collected in one place and then being sent. Similar issue with Zscaler. You have to be able to break that traffic up. So and that's often a challenge. And depending on what tools are in the toolbox of the people who are working on the Cribl project, sometimes they're like, well, we need to, have the load balancer do this. And the load balancing team is like, yeah, we're not doing that. Or, yeah, we will, but it'll take 3 months to do it. And then, sometimes you end up standing up HA proxy just because that's what you need. You need to get it done. But the other part is Splunk Universal Forwarders. We do periodically run. In fact, one of the big customers we found a few weeks ago, there was a typo in the event breaker. So giant amounts of logs were not broken properly. So we saw multi-hour pinning to a single worker process from a UF because it never knew where to break it. And there was just data kept coming in and coming in and coming in.
Yeah, the event breaker is key. That's for sure. Yeah.
I see that with reading from a file that's being kind of like, in this case, it was written by our syslog. Right. In other cases, I've seen it if your HF or UF is listening to a UDP port for syslog or TCP port, whatever. But if it's one big connection, it's just going to keep sending unless it can break it up properly.
Right. And that streaming behavior is a bear. It is a pain in the butt to deal with. Yeah. So let's talk about I'm a middle case. So my 10 terabytes a day, would that be an all-in-one worker use case, or would that be the larger architecture?
Well, to some extent, we need to see how much from each source is coming in, right?
Well, 60% of it's firewall data. So 60% of 10 terabytes is firewall data.
Yeah. So in that case, I would say we probably want to take that firewall data and put it on its own worker group that's handling syslog, using source persistent queuing to grab it off the wire as quickly as possible. We want to confirm that it's being spread across the workers and
Okay.
worker processes evenly, and that will keep that happy. Because what we want to avoid, and the reason we want to split into separate ones, if we have another source coming in and all of a sudden it spikes, all of that UDP stuff that's coming in on the through syslog, you might end up losing if the processes get too busy.
Right. That's very true. So for the syslog service, what do I need to request? Is it just cores and memory, or do I need to request something else?
Well, you got to make sure your networks are all good. And since I mentioned persistent queue, in this case, you're going to need it. You need disk and you need fast disk.
For persistent queue.
For persistent queue.
What about the destination queue?
The destination queue, if you have, the answer is yes, you need fast disk for both. It's often more important for a source persistent queue especially if you have the always on, it's always being written to disk and read out.
Right.
A destination queue is only going to kick in when it's needed. If you have source persistent queue, again, depending on a few things, you might not need a destination persistent queue. It really, we would have to see how those queues would interact. And that's one of the other exercises we usually go through, is saying, okay, you got two destinations. Which one is the must-have destination? And which one is the best effort destination? Because if you block on a destination, even if you have persistent queue, at some point, if that queue fills up, if that's the must-have destination, you need to tell the upstream to stop sending, if it can. Right. While the best effort destination is not going to block your traffic, it's going to drop once the queues fill up. So that's where kind of the discussion about queues comes in.
It's an important element of planning, especially for your resiliency, because what happens, as I mentioned before, when things fail, when your systems of analysis or your Splunk instance goes down, your queues give a place for your data to go while you're getting the problem fixed.
Exactly.
Yeah. Oh, and also one thing I want to ask. So, if I'm going to use a persistent queue, how do I do planning? So I got 10 terabytes a day. How much? And I need, let's say, an hour, or let's say an entire day. How much data do I need? How much space do I need to allocate to the persistent queues?
So that gets into the calculations of how much is each worker going to handle, because your persistent queue size, you're going to need to calculate per worker node, not per worker process, although we'll get into that in a moment. Per worker node, how much you're handling, and then how much, as you already said, maybe an hour, maybe a day. In our case, actually, when we were a customer, we said we want to handle 4 hours, because within 4 hours we can get somebody to add more space if it's still filling. Right, so we don't need it. We wanted a day, but we said we don't need to have the day allocated. We can add more later. And the per worker process part comes in is, if you're going to limit the size of your persistent queue that the worker can write, then you need to calculate that per worker process. The better option is to have a separate partition of that disk that you added for persistent queuing, and just say, fill up this partition, whichever queue is currently writing, whichever queue needs to write to it, just keep writing, fill it up, rather than trying to figure out how much to allocate for this, how much to allocate for that.
Right.
So
that makes sense, and I think that's an important part of your planning too. All right, let me think of what else we got. Would we do retention out of Cribl, or is that something I would do in my systems of analysis?
Please don't do retention in your system of analysis if you're talking about long term, because that gets really expensive. I think we did mention, right, the data lake, and that is where you want to send things for retention long term. And we have kind of on the slide there, and the concept of replay that we don't necessarily need to get into too far, but right, send to system of analysis just what you need, and you need it, and you're going to use it, or at least you are pretty sure somebody is using it. Most likely, maybe, if you can figure it out. But for retention, data lake of some sort is your best option. And then replay, if you need the data that's 11 months old and you're keeping it in data lake for 12 months, but let's say your system analysis for 3 months, you can just say, hey, I need these IPs that are talking to each other, or this piece of data, and pull it back in and push it back into system analysis so it can do that analysis.
Makes sense. All right, so. And let's say I'm going to plan for 10 terabytes a day, but with a little bit of spike. So let's call that 3 cores per T. So I'm going to need, let's call it 30 core, 30 terabytes. So actually, no. So that's right. So you met 3 times. And so it's 30 terabytes a day with all my ins and outs. And so that's going to be 90 physical cores in order to build out my stream infrastructure.
Yeah, and that's assuming you're already accounted for any spikes or busier times of day that you normally have.
Right.
Right.
So 90 cores. Another also, and this is because we're going to need to wrap up pretty soon. But worker groups, how do worker groups work? Is it so it's volume of data, it's also HA, but is it also segmentation of data as well?
Well, yeah, we talked about the case where you might want to split it up, right? If you have your syslog receivers on one worker group, so that if that gets right, that can keep processing UDP if you have that, while something else might get busy. So you want to segment data when it makes sense.
Okay. And I think this diagram that we're using is a good example of a larger architecture at 10 terabytes a day with 30 terabytes of in and out, where you would need to take that 90 cores and break up your data accordingly. So we'd have a larger syslog worker group because it's 60% of my data. And then we'd have maybe a cloud worker group for my AWS. And then we'd have an on-prem for our Splunk Universal Forwarder, our Splunk Universal Forwarder worker group.
Yeah, that makes sense. And then check the size of each and see if you need to reshuffle the numbers. Some are more specific. Like if you're pulling data down and you can just slow down your pulling when things get busy, then you don't need to have as much overhead capacity as you do in cases where it's getting pushed to you.
Okay. That makes a lot of sense. And so then, and especially so at 90 cores, that's going to give us, 125, 135% of capacity, according to the calculations. So I think that's going to be really good. We've broken up our data, so we've created some isolation that in case, say, one thing blows up, it doesn't blow up the rest of the data. We can all manage it through the leader. We're going to have options for sending data to our system of analysis, Snowflake, and also S3. So we have all those options covered.
Mm-hmm.
Is there anything else that I've forgotten?
I'm trying to think off the top of my head if there is.
So what's the biggest thing that you run into that turns out to be an issue with deployments?
Honestly, a lot of cases it's the pinning.
Syslog.
Syslog, universal forwarders also happens, or HFs. As I mentioned, like if the event breaker wasn't properly set up,
right,
then you're going to have those problems.
So those things are always got to look for and be ready to overcome them.
Yep.
All right. So that's really cool. All right. So let's have some closing thoughts. With your experience, you've worked with so many customers. So just how would you wrap all this up? Something beyond just it depends. Give us some sage words of wisdom from a professional services expert.
I mean, really, it's thinking through what's going to go wrong where and making sure that you have considered it and decided what you're okay with when it goes wrong, right? Similar to what I said earlier that I stole from somebody. But really, that's what it comes down to, right? You got to think through and consciously be ready for things to go wrong rather than have surprises.
Yeah, and I think that just kind of, getting out of the customer persona, it's really important to know how you can fail, understand your failure scenarios. And I think the thing is, as an engineer, you don't have to be able to survive everything. You need to understand where you can fail, communicate to your leaders, and let them tell you, okay, we're not going to worry about this, but we are going to worry about this, in order to give you that kind of guidance. Also, those emails, put them in a PDF, put them someplace special, wave them in the air, because when things do fail, you want to make sure that everyone knows you brought this up.
Fair point.
Because I think it's really important that if you try to address everything, you'll never get started. And so get started with the smooth, scalable architecture. I like the reference architecture. It's very compartmentalized so that you can make changes as you grow.
And that is an excellent point, because in a lot of cases, we do start our engagement. We start talking through and say, okay, we don't have enough grasp of what our issues might be. Let's start with something, because refactoring, moving things around, it's not that difficult, especially if you use something like PAX. We can evolve. right?
Yeah, and I think that's key. One thing I see all the time is they'll have like, here are 10 things that we want to do. I recommend starting with the 10th thing you want, the 10th data source you want to attack, just because it's small, you're going to make mistakes and you'll get faster feedback. So then you can use that feedback to then attack your bigger data sources faster. Because otherwise you get really mired down if you start with the hard stuff first.
Yeah.
So this is awesome. I really appreciate it. Thank you for sharing your wisdom.
Thank you for having me on. Always a pleasure.
Yep. Let's see. So everyone, I really appreciate everyone's time. We're going to have this video will be recorded into our YouTube channel. It's here. Also, please engage with Eugene and I in our Slack channel, cribl.io/community. It's a really amazing Slack channel. I'm just so proud of all the communication, all the work. There's so many people who are there, willing and ready to help you. So it's a great day. Everyone have a great weekend. Hopefully helps you solve some real world problems. And if there's something we're not talking about, please let us know. We are here to help. Right. Eugene, have a great weekend.
Keep calm with Cribl on.
There you go. Take care.